Hello and welcome to this video covering nets and surface area. I'm excited to say that I'm joined by a very special guest. His name is Uncle Bob, and he has a well-known vlog by the name of Uncle Bob's Math Vlog. And maybe you've seen a few videos of his. So anyway, without further ado, welcome Uncle Bob. Hi, I'm really glad to be here. I appreciate you having me on. Oh, of course, Uncle Bob. Anytime, you're always welcome. Well, thank you. I appreciate that. Okay. Well, Uncle Bob, it's appropriate that you are here today because, I kind of have you to thank for one of the tools that I use to help the students learn today. So, I appreciate all the work that you do over there on the Uncle Bob Math Log. Oh, thank you. You're making me blush. Well, give credit where credit's due. So we started with this warm-up, and we had several composite shapes, which kind of reminds me of our composite solids that we did the day before. But again, these are flat, and the key idea here is we want to break these or decompose them into shapes where we could find the area. And we did that with this rectangle, found 6 by 6 is 36 yards squared, and then the remaining 4 times 2 would be 8, and this would also be 8, and then we add them together to get 52 yards squared. Okay, and we did a similar thing here. Okay, this sets us up really well for the idea of a net, which we'll see here in a little bit. All right, so a net in math is a two-dimensional or flat representation of a three-dimensional geometric figure. All right, kind of referred to it kind of like the wrapping paper. If you wrap a box with wrapping paper and then you unwrap it again, not including all the stuff that got folded under or taped under, just the part that was on the outside surface, that is going to be the net. All right, it's a flat representation of a three-dimensional shape. So it's just the very outside surface, the wrapping. All right, now why in the world are we talking about a net? Well, the net helps us to find the surface area, and I think this got a little bit off, so let's drag this down. All right, sorry about that. So surface area is the total area of all its two-dimensional faces. Sorry, surface area of a polyhedron. Remember, polyhedron is just a three-dimensional shape, and it's the total area of all its two-dimensional faces. So it's the outside only. All right. So I wanted you guys to look at this and look at the response of Letitia. All right, and Uncle Bob, I'm going to have you take over here and kind of explain, if a student was asked to find the area of a face of a cube, why are these responses, one correct and one's not? Okay? Okay, well, let's see. Letitia says this is a 3D figure, which means that its measurements are cubic units. Well, I agree. 3D figure is cube, and most 3D figures do have cubic units. But I think when we're talking about surface area, we are talking about square units. It says area is always a square unit. Well, I think that's a pretty good point, Uncle Bob. So though we're working with three-dimensional shapes, surface area, again, is just talking about the outside space only. That's right. That's right. That's what we're talking about. Yeah. So surface area is still measuring area, which is always measured in square units. So I like what Isaiah said. He's got the right idea. Okay, I think you're right, Uncle Bob. So here we go. We took a look at this net of a cube, and we wanted you guys to come up with a strategy. How would you find the total surface area? And a lot of you correctly said, well, if we find the area of one of these faces, then we could just multiply it by 6, because since it's a cube, they all have the same area. Okay, and you were right. So we find 2 times 2 is 4, and then we multiply that by 6, we get 24 inches squared. All right? But then we ran into this challenge. All right? This is not a cube. This is not a square. And again, remember, the number one rule in geometry is not to assume anything about the drawing, just based on the drawing. So we have to use our brains to kind of figure out and piece it together. And what we came up with is, to find the area of this rectangle, we need to multiply length times width. But the width wasn't written up here. We had to go down here to get that information. But remember that each of these lengths is the same amount. So this would be 5.7 centimeters. So to find the area of this, I would multiply these two numbers and find this area. All right, then over here, we know this width is 2.9, but what's the length? This one's a little bit trickier. You kind of have to picture this being folded down on this side. All right, I wish I could do that in my video. It'd be really cool. Okay, I'd fold it down, but this side is going to be the same as this side. So since this side is 4.3, this side is going to be a 4.3, because these edges would connect when I folded this net back together. All right, and that's a big piece to figure out the lengths of a net. So 4.3 times 2.9 would be the area of this. All right, and then this green square, we know that the width is 5.7, but what's the length? All right, well, the length is not necessarily going to be this, right? We have to go, because this is connected to this. This would fold over on top of this. So you kind of have to translate it in your brain a little bit. Okay? So the 2.9 and this 2.9 match up. All right? So our area would be 5.7 times 2.9. And then notice I color-coded it. This flap is going to be the same as this flap. This is going to be the same as this flap. And this is going to be the same as this, which kind of sets us up for what you are going to tell us about, right, Uncle Bob? Yeah, that's right. That's right. We're almost there. Okay. All right. So this page, page 147, is very much the same. Just don't worry about these trapezoids. Those are the flaps that you glue in order to put the net together. Kind of wish they weren't even there. It's a little bit confusing. But just disregard those. You're worried about these rectangles. All right? And I think your assignment is very similar to this. It just has different numbers. So refer back to this page when you're working on those. Okay, find the area of each of those rectangles and then add them all together. All right, now let's get into this. Uncle Bob, you want to take this away? Yeah, you can watch a video on my website about SARP. Okay, I've got some funny jokes to go along with it, but we don't have time for that right now. So when I talk about SARP, I talk about the surface area of a right prisms. Okay, and the translation is, what's the surface area of this box? All right, the mathematical term is a right prism, a rectangular prism. Sorry, I forgot what the R was. Oh my. Okay, anyway. All right, okay, we're moving on. Anyway, in order to do the SARP, I need the TBRLFV. Okay, the TBRLFV is the top and the bottom, the right, the left, the front, and the back. All right, so I look at my rectangle and I find the top. So I find the area of this right here, and then I know that it's going to be the same as the bottom. Because the top of a cereal box is the same size as the bottom, or tissue box, or whatever kind of box you got. All right, so the top is the same as the bottom. The right side is the same as the left side. And then the front right here is the same as the back. So if you can find the top, the right, and the front, you just kind of cut and paste and double them and then add them all together. And then you got your surface area. This checklist kind of helps you to remember, do I have all of the sides, all the faces represented so that I get the right answer? Well, that's great, Uncle Bob. I think that's a really good, helpful memory tool. So TBRLFB. That's right, TBRLFB. Okay. So there is basically your assignment. It's a page very much like this, just different numbers. Hopefully this video is somewhat helpful. Thanks for watching. And Uncle Bob, thank you for joining us. Oh, it's been a pleasure. Thank you very much. All right, bye guys.